So we're going to solve this projectile motion problem. We've got Mr. G laying on the roof of the school, which is 12 meters above the ground, and he fires it horizontally. Okay, so let's picture this thing. Let's put a horizontal ground here. We'll make a building up here. This building is 12 meters high. That says 12 meters. We'll put Mr. Gaglardi up here. So here's his head. Here's the little body, some legs. I don't know why he's lying down, but if it's going to be Mr. Gaglardi, we better make some hair on that thing. And for some reason, I don't know if I can get this right, but here's his arm, and right here is like this little projectile, this dart gun. He's going to fire this projectile, and it's going to do something like this and land somewhere over here on the ground. One thing to keep in mind, when this thing lands on the ground, in part C it says what's the velocity of the dart as it hits the ground. This is as it makes contact with the ground. So not after it hits the ground, bounces around and stops, but as it hits the ground. So how fast is it going? If you want to think of it like this, how fast is it going just before it hits the ground? Just before it hits the ground, you could say that the dart is right there. It's actually heading in this direction. Okay, so when we find V final for part C, we'll come back to this when we get to part C, but just keep in mind, this is what we're looking for. There's V final, you could call it V2. That's going to have an X and a Y component. So we're going to have to solve for V2X and V2Y. So we'll get to that later, but just keep that stuff in mind as we go through this question. For part A, we're told that the dart is fired horizontally. So that's way back over here. Let's see, maybe I'll flip to a different color here and just note V1 is right here. There's V1, kind of parallel to the line. V1 is horizontal, which means when we start looking at our X and Y components, V1Y is going to be 0. So let's do that. Let's start looking at our X and Y components. Alright, so here's Y. I'm going to start with Y, and we'll do X. Maybe I'll see if I can squeeze that in right here. Let's do this. When we start looking in the Y direction, a couple things that we always know, right? We always know acceleration in the Y direction. If this is a projectile, acceleration in the Y direction is 9.8 meters per second squared down. Just to save a little bit of space, I'll say 9.8 meters per second squared. Let's see if I can I have trouble with 8s for some reason. Let's see if I can get this 8 to look good. 9.8, there we go. And there's a decimal right there. When I said negative, I should be good and say this over here. I'm going to choose forwards as positive, and I'm going to say up is positive. Okay, so there's a positive right there. If up is positive, then down is negative. This is 9.8 meters per second squared down. That's why it's got a negative sign. We also know, again, because this projectile was fired horizontally, we know the initial velocity in the Y direction is 0. It was not fired up or down at all. It's fired exactly horizontal. So there's no up or down component to that. We also know displacement in the Y direction. Remember, this thing starts on the top of the school and ends on the ground. If the school is 12 meters high, this thing falls for 12 meters. And just keep in mind, if it starts at the top of the school and ends on the ground, it's falling down. So I'm going to go ahead and say that the displacement is negative 12 meters. You could say it's 12 meters down. We're going to try to solve for time. So we'll come back and look in the, well, let's look in the X direction now as well. And again, just like we know, acceleration in the Y direction is always negative 9.8. Acceleration in the X direction, always 0. That's true for projectile motion, always. I don't know what time is, okay? That's a question mark. But I do know initial velocity. I do know V1x. Remember, we're told the dart is fired at 14 meters per second. That is all in the X direction. So 14 meters per second. All right, let's look in the Y direction first, because we're going to try to solve for time. So I'll come up here and I'll say Y direction one more time. I'm looking for an equation that has D, V1, A, and T in it, and that's the aptly named best friend equation, affectionately called the best friend equation. We know distance, V1t plus 1/2 at squared. We know our displacement. Now it's really just subbing in numbers. We know our displacement's negative 12. We know v1y is 0. Now remember, 0 times anything, 0 times that time, crosses that whole thing out. We've got acceleration, negative 9.8, and here's t squared. So we can clean this up a little bit. We can say negative 12 equals negative 4.9 t squared. Remember, that's half of 9.8. It's 4.9. When we're at this point, I want to try to get t by itself. So I'll divide by negative 4.9. And if I do it on the right side, I have to do it on the left side in order that it remains equal. My 4.9 and 4.9, those two negative numbers, cancel out. What I'm left with then is t squared on this side, and 12 divided by 4.9, what's that, 2.449 approximately. We take the square root of both sides. We can get t is approximately 1.5649. I'm going to keep lots of decimals. There's the answer to part A. So here's part A of the question. I'll just say here, there's the answer for part A. Part A says, what's the time that the dart is in the air? The time that the dart's in the air for, now I should do sig digs on here. So let's go ahead, let's just back up a little bit here and say that it's about 1.6 seconds. There's actually the answer for part A. Let's go like that. So there's my answer for part A. For part B, let's see if I can squeeze it down here. The answer for part B, we're asked to find how far from the school does the dart land. That's in the horizontal direction. In the horizontal direction, if you think of the best friend equation, distance is v1t plus 1/2 at squared. And just keep in mind, I should have said this right at the top, but I'm looking in the x direction here, not the y direction. Because ax is 0, this whole thing right here, cancels out. Remember, if acceleration is 0, 0 times 1/2 is still 0, times t squared is still 0. This is always going to happen in the x direction. Really, the only equation that I've got is distance is v1 times t. We know what v1 is. This is v1 in the x direction. It's 14 meters per second. The time, I'm going to use my unrounded time. So that top box, 1.5649. Oh boy, let's try to get those letters just a little, those numbers a little clearer. 1.5649, there we go. When we multiply those two things together, the distance in the x direction is 21.9 meters. And again, for sig digs, we're going to have to round that. I'll say right here at the bottom, dx is 22 meters. And put a little box around that. Remember, the question asks, how far from the school does the dart land? 22 meters from the school. Okay, there's the answer for part B. When we start moving on to part C, let's piece of paper, or clean screen, I guess. The answer for part C, let's see, what was the question? What's the velocity of the keys as they land? And again, this isn't after they land and bounce around on the ground and eventually come to rest. This is the instant as they're hitting the ground, how fast are they going? And remember, before I mentioned, we're not looking for the x component, we're not looking for the y component, we're looking for v2. To find that, though, we're going to have to look in the x direction and find v2x. We'll have to look in the y direction, find v2y, and then put them together. So something that I remember always is in the x direction, and that's an x there, v2x is always equal to v1x. Okay, this is always true. Why is that always true? It's always true because acceleration in the x direction is 0. So if you start off going 14 meters per second, in the x direction and you don't accelerate, you're going to end up going 14 meters per second in the x direction. So v2x, 14 meters per second. You could again say forwards if you want. There's our x component. That's kind of the easy part. The harder part then is what's going on in the y direction. So let's break this up a little bit. Maybe we'll do this. In the y direction, we had a bunch of stuff on our previous screen, but just to get it back up in front of us, we know AY negative 9.8 meters per second squared. We said before V1y 0, that's still true. Displacement in the y direction we also know, negative 12 meters. We also just figured out time. Time is 1.5649 seconds. You've got your choice. We've got lots of different equations we can use. We're trying to solve for v2y. I'm going to go ahead and use the simplest one I can. So v2y is v1y plus at. I'm sticking a bunch of y subscripts in there. Just to remind us we're in the y direction here. v2y, v1y we've already set as 0. Acceleration, negative 9.8. Time, 1.5649. Again, I'm using the unrounded time here, not my rounded time of 1.6. We solve for v2y, and we get negative 15.34 meters per second. Okay, and just a reminder again, we're not looking for v2y. Just like above, we said we're not looking for v2x. We need to put those two vectors together. So this is just like when we have used component method. We've just solved for v2x, and that's 14 meters per second. We've also just found v2y, and that's 15.34 meters per second. This is what we want. So this hypotenuse side, that's v2. And just a reminder, when we're looking for v2 as a vector, we're going to need to solve for an angle there as well. Okay, so I'm going to solve for the angle first, just because, I mean, let's face it, solving for angles is a lot of fun. I'm going to use tan. Tan is opposite over adjacent. So tan is the opposite side over the adjacent side. And don't forget to hit, when you divide those things, you're going to hit inverse tan. That is about 48 degrees. Make sure you're in degree mode on your calculator. Stick a little box around there. We're also going to need to solve for v2. That's just using Pythagoras. I know v2 squared is equal to 14 squared plus 15.34 squared. Don't forget, square those two numbers, add them, and then square root. We're going to get v2. Let's see, that's about 20.76 meters per second. Again, I'll stick a little box around there. None of these are our complete answer. Remember, to have a complete answer, we need to say v2 as a vector is, we need to round that for significant digits. It's about 21 meters per second. And then the way that we write this, we're going to say it's this angle, 48 degrees, and that's below horizontal. Try not to say it's east, 48 degrees south, because remember, down and south are really not the same thing. This is 48 degrees below horizontal. Let's change, let's see, what can I get here? Oh, nice flashy red color. This thing right here, this is our final answer. All those other boxes are just pieces to the puzzle. There's our final answer. That's the answer for part C. So we could say answer part C. And we're done. That's it.